Mickey, can you take care of this? If the person joins back, can you remove? Is it possible? Because I'll be sharing my screen, so I might not be able to do that.
Yeah, I'll keep an eye.
Okay, thank you.
Harsha, if you're talking on mute.
You're on mute, Harsha.
Oh, sorry. Let me know once you're able to see my screen.
Yeah, we can.
Yes, we can.
Okay, we'll get started. Okay, welcome to this week's six of our AI with TensorFlow masterclass. It's going to be the last session for this masterclass. We have a few topics to cover. We'll also look at another application of machine learning, deep learning methodology in another area called natural language processing today. So we'll see, we spoke about how neural networks can be done with TensorFlow and Keras, and we are going to extend it a bit to take it to a type of neural network, which is recurrent neural networks, which will be used heavily in NLP type of model building. So we'll start looking at introduction to NLP and also see how recurrent neural networks will be used for that. Okay, NLP, natural language processing. So what is that? So this is the definition from Wikipedia. It sounded very nice, so I just copy pasted it. It's a subfield of linguistics, computer science, and artificial intelligence. Okay, what does it deal with? It mainly deals with interaction between computers and humans, human language in particular. See how you can program a computer to deal with human language is what NLP is. When you try to do that, the computer understands, say, what you speak, what you write, what is there in the documents. And when we say understand, it also understands it to a level where it can get the theme of the article or take an action based on what you say. All these things can be done. When these things are achieved, you build applications with which, like, you make processing of a human language much simpler to a computer. What are the various applications? Once I give the examples of applications, I think it will become clearer to you. Some of the applications where NLP is used: search engine. You would have seen, like, you open google.com and then you start typing the words. You start getting suggestions as to what the next set of words are going to be. So this is a classic example of NLP in action. All of us have, like, many of us have seen, like, in website, when we are typing a mail or something, we get suggestions about grammar corrections or what is the right word to be used. That is also an example of NLP application. Another usage where you find, like, the world is definitely benefiting a lot is the translation part. You see, Google has a translator. Like, you want to translate from one language to another language, it becomes a lot simpler. I know IT has led to globalization, where interaction between various countries, various communities have increased, and language barrier is one of the barriers which we need to overcome, amongst other things. And here is an application which helps you do that. And what is behind the application is NLP. These days, there are many companies which have started using chatbots. Like, you go to a service request page, you start typing, you get a message saying, hi, I'm so and so, how can I help you? And based on what you type, there are suggestions. And chatbots also use NLP. There are many places where people enter their comments, their opinion. Like, if you're going to take, for example, there are products and there are product reviews which are associated. There are tons of reviews which are there. It would be humanly impossible to go through each and every review and make sense of what that review is trying to convey. To help uh, this, NLP has sentiment analysis where it goes through the passages and then tells you like what the review tries to convey, whether the person liked the product or not, or what are his major comments. If you want to, if a company is trying to build a product based on or do some changes to the product based on the reviews of its previous releases, what it can do is it can go do a sentiment analysis, understand what is the feel of the product, what are the good features, what are the bad features, and then decide what to retain, what not to retain. Taking NLP to the next level is the text generation, where people have started using deep learning techniques to do text generation. That is, you have a particular way of writing. There is a style of writing. What happens is you feed that into the model, and it it understands the style of writing and it tries to generate text on its own. That's the next level where NLP is already moved into. I would say it's still an area which needs improvement, but that's something which we can count as a frontier in NLP. These are some of the applications where natural language processing is being used. Uh, this is like what we have seen so far in terms of like market basket analysis or predicting home price, all those things. That's one type of machine learning. NLP is another type. When I say type, I'm not talking about supervised or unsupervised. I'm saying another application of machine learning where there are a few things which become characteristic of this. For example, like sequence of words, the importance of grammar, all these things, the punctuations, the way you see how the different characters which are there, languages, it's not restricted to just one language, many languages. All these are dealt with in NLP. How you want to deal with that is something which there are several libraries which help you deal with how to decode what is written or what is said and take it forward to uh, achieve the result which we want to do with the model building. Any questions about introduction to NLP? Okay, I'll take that as a no. I'll proceed with some of the aspects of NLP. So we spoke about natural language processing and what needs to be done and what are the different applications. There are few terms which are associated with natural language processing, and I'm just introducing you to these terms. I'm not going to deal with them in detail, like or show you the application of these things, except maybe one or two, but I'm going to introduce you to these terms so that like when you hear these things, you will be able to understand in a better way. So the first term we are going to see is regular expression or regex. It's just something which I think all of us will be familiar with, making a pattern out of a text. A sequence of characters to create patterns is what we would call as regular expression. Say if you have a text and if you want to find a particular say the dollar amount, the wherever the dollar amount is mentioned, then you have an expression which is going to be dollar and the number, right? So that's a pattern which we can watch for. If you want to filter out those values and see whether you want to do a particular analysis with that, that can be done with a regular expression. So regex basically is, I just gave an example of dollar amount, but it can be used for any pattern, maybe with how you denote names like Mr. James, Mr. So-and-so or Mrs. So-and-so, Miss So-and-so. So these things are all regular expressions which you can build and check for a pattern to get, to clean the data from the text and do your analysis. So that is regex for you. Token. So you have text, right? So when you have text, you have a huge uh, sequence of documents. Documents will contain paragraphs. Paragraphs will contain words. Words will be split into tokens. Words or sentences will be, sorry, paragraphs will contain sentences and sentences will be split into tokens. Uh, I'm deliberately avoiding the term word because token can be the smallest unit of text, which can mean that it can be a word, it can also be a character, depending on what you're going to apply it for. So some of the things you will come across when you're looking at NLP algorithm is tokenization, which you will try to do. So there are libraries which support tokenization. For example, Spacey supports tokenization to a good level. Tokenization is basically shifting the sifting through the text which is provided for your analysis, and splitting into the smallest unit of text that is possible. When you're doing that, you will of course come to the vocabulary, which is the list of unique words which are possible in that particular text. So coming back to tokenization, what happens is you can do it. A simple way of tokenization is a white space tokenization, where you just split with the space as the separator. So wherever there is space, you can split that. Like if you're seeing two words with a space, then you create two tokens with those two words. But there are few issues which arise due to that. For example, like if you're looking at say there'll be it not everything is that way, right? So if you want to split it into, say, dollar example, some people write it as dollar $10,000, and then you want to split it into dollar and 10,000. In this case, there wouldn't be a space, so you might not be able to tokenize if you're just using based on white space tokenization. So what Spacey provides is there's a function which like you can do the tokenization in a better way. They take care of various other conditions. Uh, the library is trained for going through some special characters and understanding whether it should be split or not, and tokenization is done properly. So this is something which we need to remember. You'll come across when you're dealing with NLP algorithms. Tokenization will be there. Other type of tokenization is regex. Regex is like you create a regular expression and do the tokenization based on that. But it's very difficult to create a regular expression for each and every possible word or each and every possible parameter within the text and then do the tokenization. So it's better to use something like Spacey tokenization, which will be helpful for us. When you're dealing with text, you also come across what is called as stop words. These are very common English words which are there to make sense from the sentence, right? Like you have articles, you have prepositions, all these things. Sometimes they might be helpful, sometimes they might not be helpful. So we should look at a possibility of stop word removal when required. So there are libraries which support you with that. In some cases, they might be required. Like for example, like you want to do translation, you need to account for each and everything, every word in the whole passage for you to make sense of the word and then translate it to another language. So there stop words removal might not be required. But if you're looking at, say, caption, generating a caption for a text, or if you're looking at classifying text, then these stop words need to be removed because they might add to the noise. And many of the passages have a lot of these stop words. If you see the word count, it will be much more than what you would have for the words which convey something meaningful when you're looking at text classification or caption generation. So stop words removal is a step which is also done in an NLP algorithm. Other thing which is also done is normalization. That is, sorry, it's not root work, it's root word. It's a typo. So you convert the various possible expressions of a particular, say for example, run is the root word, and then you have running, ran, have run, all these things. You look at converting it to the root word. There are two methods which are being used: stemming and lemmatization. Stemming is more like just removal of ing, or if there is a plural, removal of es or yes. That's not a very scientific method. Sometimes like his is also split it as hi and yes, so that is not very useful. So lemmatization is another method with which like you have root words for different words. So lemmatization is a better technique to use for normalization. So these are different terms which are associated when you're dealing with NLP algorithm. Depending on what you want to do, what you want to build, you can use many of these. As I said, like I'm only introducing you to this. I'm not going to look at details of these things or look at the application of all these things, but it's not a bad idea to remember these things when you're coming across NLP algorithms. Now that we have seen the terms, I'll quickly talk about a library which is used for doing natural language processing. I'm not getting into the TensorFlow part of it. This is other library where you have the it is built for natural language processing. Spacey is the library. It's for advanced natural language processing. It supports you with various aspects that are required for natural language processing. For example, if you're looking at tokenization, if you're looking at stop word removal, uh, if you're looking at normalization, all those things are supported by Spacey. You can use this for doing that before you go to do the actual model building. So this is something which like what pandas helps you with, right? So it's also you can pre-process the text before you get into the actual model building. So Spacey is a library which we can use. There is also another library, a bit old one, NLTK, which is Natural Language Toolkit. That is, it's also widely used, but it's not. It's a bit old, so it's not very efficient. But it's memory efficient, not runtime efficient. That's what I read. So this is just to introduce you to a library which will be used prominently for natural language processing. Okay, before I get to recurrent neural networks, can we pause for the survey? Okay, and as Kader mentioned, can we? Okay, how many of you have filled the survey already?
For sure, I did it.
Sorry,
I did it.
I'm sorry, your voice was muffled. Can you please repeat?
I said I done. I'm done with it.
You're done. Okay, okay, thank you. But I still see only 8 responses, not from everyone. For those who haven't filled the survey, can we quickly do that? I'll pause for 5 minutes. Okay, I'll stop sharing my screen for 5 minutes and then we'll see the number after 5 minutes. Will that be okay? Okay, I'll take that as a yes. I see that 2 more have filled. Okay, one more. I think it's not going beyond 9. Can everyone fill this survey, please? If someone hasn't filled. Yes, it is 10. Yes. Okay. Other quick question. Are you online?
Yeah, Harsha.
Yeah. How do you want to go about it? It's 10 responses so far.
I'll let you make the decision. So I intentionally wanted you to do it. If you believe, okay, 10 is good, go ahead and see what is important for you, that you believe something that you wanted to share it with the team, right? Share it if something is interesting, and then move on with your session.
Okay, I'll not go through the location related details or the attendee related details. I'll talk more about the session because that is important, and I think that's something which we need to discuss in this session too. I hear that many of them have rated the course high. I see that many of them have rated the course high, and they've also given me a good rating. Thanks for that. Um, I would also like to know if there are people you can use Teams to convey the message. I would like to know whether you need to change something, or you want me to change the approach, or if you want me to focus on something. That is something which will help me plan for the next course, because we are planning a detailed masterclass on NLP that is planned in the second half of the year. So it will definitely you can definitely you know give your thoughts on how you want us to handle this. I've tried few things with, a good mix of theory, the practical portion, try to explain real world examples, and also showed you a bit of code, how things work out. If you feel that the code part is a bit boring, you don't want to do that, you want it to be given as an exercise or something like that, please suggest. Or if you feel that I need to spend more time or give you a code walkthrough itself, that is also okay. Let me know. So um, let us communicate and make it very clear so that it will help us plan our sessions in a better way.
So Harsha, what I can do is I just share your screen. So it's good that you covered it as a speaker of the event, right? As a program organizer, let me share a few words, right? If you can share the screen, which I cannot right now, I would appreciate, please.
I'm doing that. I've got the results.
So, all right. So we have total of 10 responses. That's really good, right? And if you look at from the organizer point of view, the diversity is very important. Are we having people from closed group, or we having people from different groups? So demographic is very, very important, because that's the only way we can bring in different people to learn and together and grow our upskill. So from that point of view, if you see the gender, we are more or less 50-50 between male and female. That's really good. And as far as the age is concerned, most of us are working adults, right? So the mostly the working adults are the one who are actually attending, not the youths or people who wants to really come in and do, right? So that's pretty clear. And a lot of people are from Canada. That being a Canadian organization, that says it pretty nicely. Okay, so let's go down. Education level, this is critical in the sense that 10th one, right? Harsha, please. If you look at this one, most of them, it's kind of distributed, right? From the demographics level, this is really good. So you can get a feel of even the two postgraduate people are coming and learning and upskilling an AI in a training. That says something, right? So it's a lot of people who are even postgraduates wants to learn these kind of things. That's the message it gives. This is very, very important to understand. And are we all immigrants? The answer is more or less yes. And we say not applicable, there is one person. That means there is a citizen, who is born and brought up here is that person, right? So that's great. And as far as this racialized status, very, very important. And if you see here, it's mostly 9 people are from Asian background, right? But we need to have more people coming from other status as well, which is critical for the success. Moving down, a lot of people are unemployed. This is what I wanted to stress on. See, we are 6 people who are employed here, 3 people who are unemployed. So you can take help from 6 people who are employed here. Build a relationship, right? Go to the channel, in the masterclass channel, talk to people, get yourself introduced. Just coming and learning means nothing. Right? You can learn not from Harsha. You can even go and join some course outside and you can learn AI. But that's not the only value add of this community, nonprofit community, we all together. The value add is how we all can help each other to get employed. And there is a job channel. You got to go and look at that. If someone who's already employed, if you have an employment in your company, put your jobs in the job channel, in our channel, so that the people who are not unemployed can get a job. You would be doing and helping a person with his life, right? These are all the things that are very critical being in a community. It's not just coming and learning, it's more than that. Please go down. If you go down to the work experience level, you see here, there is almost like, there's a senior vice president, someone has joined, and there is 4 managers, and rest of them are engineers, right? So the person who is manager and team lead, you can get help from them. Right? If you want to, you got to reach out to them. It's not just coming here. Reach out to them offline, and who are all the people have joined. Most of them are in the channel. So talk to them, find friends, and become friends. And that's the only way you will become successful. I'll tell you one thing that I've learned after coming to Canada. Knowing people and helping each other is the only way that we grow together. Knowing AI, knowing coding is secondary. Trust me. You will not realize that now. You will realize that as things, things start to happen in your life. And as you get more and more experienced, please go down. So work experience level. So Harsha, this is critical for you to understand. Like as a trainer, you have people who are like postgraduates and more than 10 to 15 years of experience are joining in your session. And 2 person who's more than 20 plus years of experience is also joining your session. This is very, very critical to understand what kind of a people that you are catering it, right? And this is crazy. This is interesting. And you see here, most of the people are from IT management and product management. Nobody is from R&D. This is quite interesting. And why? Something to really understand, right? And industry experience, it's kind of distributed. That's a good sign. Technology experience, if you go down, to wrap this quickly, AI, 4 people are AI, but all other people who are not AI wanted to learn AI. That's good. So you have people who is working on AI coming and learning from you, and also people who are not working in AI coming and learning from you. And this is a very important thing especially for the speaker, because everyone strongly believes that attending the program, they have developed their skills. This is very, very important to understand. After being a Testoper community, has it helped? Some people have got certification, some no, and yeah, this is really good. Go down.
Kader, 1 minute. There's one person who has said neither for this.
Yeah, which is okay, because this could be a person, that person could be joined for the first time this session, and he's never joined the previous Testoper session, so he never got a certificate from Testoper. And those people, whoever are attending now, whoever has 80% or more attendance, everyone will get a Testoper certificate of attendance, right? So I will quickly ask you to share.
Okay, this is okay, fine. This is not with respect to this particular. Okay.
Yeah, achieve professional growth. It's actually good to see 4 people have improved the performance, and someone has become an entrepreneur, and others are 5. So that basically means it's not applicable for them. Rating is really good. All are above 4.9, and this one is not applicable partner. If you go down. So this is critical. Whoever is attended wants to volunteer. So there's already 6 people are volunteering. Whoever has applied the survey, 4 people who attended, they just wanted to be an attendee. They don't want to volunteer. I have a few words for you guys, right? My sincere recommendation is get it and also give back. Right? That's the only way in Canada we can survive together, right? We got to somehow give back, right? Just one way is never going to help us to become successful. Go down. That's pretty much right. I wanted to share it from the program organizer point of view. You understand who are all the people who are associated with you when you are learning this together, and how important it is for you being in Canada to build this network, be part of this community, and become successful. So with that, Harsha, I'll give it over to you. Probably this also gives you a good understanding as to next time how to do it from the wearing the hat from the program organizer point of view.
Okay, because I had planned it a bit differently. Maybe we should have spoken before this. That's okay.
But this is the standard thing that we wanted to do, because this is what the government asks us to report, right?
Okay.
There may be something you might ask which will help you to improve your program, but that's secondary, right? But the most important thing is you all have to understand as well. You 10 people have filled this survey. You don't know how good you have done for Testoper. These data actually goes to the government, and it says these are all the things that we are actually achieved as a Testoper organization by providing these things free for the people, because we are all volunteers. We are doing this, taking our time, and we are trying to help our government to grow and our community to grow, our society to grow. And first of all, I wanted to really thank those who have filled it. You have done great help by doing this. So Harsha, if you can go to the teams, I just want to show you one thing, and then I'll leave the floor to you. Go to the teams and go to Testoper Hackathon. Testoper Masterclass. Yeah, go to files, please. Yeah, so here, team, you will get another folder in 2 weeks' time after this session called certificates. Okay. Or can you also go to the general channel, please? Harsha, sorry, apologies. General, go to files. I want to make sure one thing here. Oh yeah, it's not there. Okay. So in the Testoper Masterclass, what you would do is you will get a folder called certification, and those who have attended 5 sessions out of 6 sessions, you will get a certificate of attendance from the Testoper community. And our programs team will make sure, right? Programs volunteers will make sure that your folder is available here, and the certificates, whoever is eligible is kind of posted it in here. So for those who wants to get the certificates, this is the place to go and look for it and get it after 2 weeks of the session. With that, Harsha, over to you. Thanks for sharing the screen.
Okay. Thank you.
Bye.
Okay. So coming back to the topic, we spoke about natural language processing, what it is, what are the different applications, what are the different terms that are used in natural language processing, and we also had a very brief look at a library which will be used, Spacey. Now I'm going to slightly deviate and take you towards how TensorFlow can be used for natural language processing. Before I get there, I need to introduce you to a type of neural network which is called as recurrent neural network, which will be used for natural language processing. So I'll start with the introduction for recurrent neural networks. So I'll repeat what I had done was I just introduced natural language processing, some of the terms that will be associated with that, and what it is used for. And now we are moving to, since this is a masterclass for AI with TensorFlow, we are going to move to how TensorFlow could be used for doing natural language processing. So for that, I'll introduce you to recurrent neural networks, or RNN. Okay, a recurrent neural network, it's a type of neural network which uses sequential data or time series data. So what we had seen so far in neural network is we saw a set of inputs being passed through hidden layers and then to get the output, right? And in this, like each of those layers had some number of nodes, and there were weights attached to each input at each node and bias attached to the layer itself. In this whole thing, there is no relationship between the value calculated at the node during the first pass and in the second pass. I'll repeat. What happens is when you have a normal neural network, you have a set of inputs being passed through hidden layers to get the output. The hidden layer will have different nodes, and each of these nodes will take a weight for each of those inputs, add a bias to the layer, and then pass this on to the next layer through an activation function. That is what we saw in a normal neural network. In this whole process, this is you pass the input, and then it starts with random set of weights, gets the output. This is forward propagation, and then depending on the error, what it does is it tries to adjust the weights and bias, and that is backward propagation, right? In this whole thing, if you're looking at something like a time series type of application where you need to take into account what the previous value or the previous instance value was there, that was not supported in a normal neural network. So that is where recurrent neural network comes in. What it does is it takes in there is a time plane which comes into play. What it does is it not only considers the current value of input, weights, all those things, it also stores the previous value that was computed in the node and passes it as one of the parameters to get the output. In simple terms, this will be useful in case of, where you have a sequential thing. Like, for example, you want to calculate how the stock price has been changing over a period of time. You want to predict how the stock price would be after this change in the stock price over a period of time. So you need to take into account what the previous values were for you to compute what the future values are going to be. And this will be very much helpful when you deal with natural language processing algorithms, because, say, for example, translation, there is a sequence of words which need to be taken into account for you to determine what you want to achieve. Like, for example, if it's translation, of you're trying to predict what the next word is going to be, those things, the complete sequence has a role to play. That is where you have recurrent neural network which comes in. It is predominantly used in many applications, like popular applications like Siri, voice search, Google Translate. All these are some examples where these things are being used. So basically, this is a type of neural network where you have a sequential data processing need that is taken into account and that is taken care of. I'll pause here for questions. It might not be very clear in the first go, but let me know if you have any questions. I'll explain it again. Should be very clear then. OK, fine. So I'll take the answer as no for the
I
question.
just was trying to
Yeah.
figure out like what was like the difference and common ground for the regular neural
Neural
network
network
and
and
the
this one.
RNN? Yeah, I know you explained it, but I kind of missed it a little.
Okay, fine. I'll explain it that again.
Thank you.
So what happens is for a particular node, if you look at, okay, I'll try to go back to my week. I don't know which week. I'll have to find that out. I'll go to maybe week 4 slides, or just give me a minute. I'll have to find that. Okay, if you remember one of the previous sessions, what I had covered was how the processing is done in a node, right? So you have the normal neural network where you have different nodes in a layer. You have like, this is the input layer, you have the hidden layers. So what happens is like the inputs are passed to a particular node, and what happens at a particular node is you have a weight that is attached to the input, and for that layer you attach a bias and you do that. After that you apply a transformation function and you get the output. This is what is being done. There is no storage of what the previous computation of this node is. Samil, are you with me?
Yes, I'm listening. Yes.
Okay, so
Sorry.
there is no, what happens is in the forward propagation, the previous value that was computed in this node was not taken into account for determining the output. But in a recurrent neural network, you have a previous value which will be taken into account. I've simplified it a lot, but to give you the concept, the previous values of the computation at this node will also be taken into account to determine the output. There are transformations or there are transformations which are applied activation functions, and you get the output including the previous value that was computed in that node.
Okay.
Where this comes into play will be like if you're looking at a time series type of problem solving, like where you're looking at how the trend has been. We gave an example of a stock price, right? So the stock price has been behaving in a particular way, say for the last 6 months, the stock price has varied in a particular way, and you want to predict how it is going to be in the next 2 months. Okay, so you need to take into account what the previous values were for you to compute the new value, right? There is a time plane which comes into play. So that is where recurrent neural network will be used.
Okay.
Extending the stock price example itself, you look at a line, say if you want to find the translation for a particular line, you should know what are there is a series of words, right? There's a sequence of words. I gave stock price was more with time as x-axis, but if you look at it in a sentence in an NLP application, there is a sequence of words which are there, right? And you need to take into account the sequence for you to either do the translation or predict what is going to be the next word. Say when you're typing make hay while, if you're typing that and Google is suggesting while the sun shines. Okay, so it means that it takes into account that make hay and not just while. Okay, so there is a sequence. The history is also taken into account for you to predict what the next word is going to be. So you need the nodes, the neural network nodes, to account for those things. So there is the previous value that is computed in that node which is taken into account, and the output is predicted. This is done at all nodes level, and then the output is given. Did I answer your question, Samuel? Hello?
Yeah, can you hear me?
Yeah.
I'm saying, is the computational time is the same for both?
No,
more
it is not going to be the same. It is
same?
going to be a lot more rigorous, right? Because you have more computation that takes place
So
in the
the work time will be longer, will take longer to process.
yeah, it would take longer. In fact, the notebook which I'm going to show you, I'm not going to run the code. I'm going to just walk you through the notebook, because if you train the model, it will take more than an hour. You'll have to just keep watching the screen. So it will be more computational. It will be more computational intensive. Yes. Because at a particular node, it's not just taking the input at that instant and then doing it, right? So it's also taking the previous computation value which was at that node and then doing extra computations to come to a conclusion, right? So it will be more computationally intensive. The need is what I explained, why you need to do that, because some type of data or some type of analysis will have to take history into account, or the sequence of events into account, not just history, because neural network, if you're doing a supervised learning, you're definitely taking history into account, like what the past values were, and then trying to predict it. What I'm saying is not just the history, the sequence in which it happened also has a role to play. That is where recurrent neural network is helpful.
Harsha, I have one
Yeah.
question. It may
Yes.
not be related to that, but in general, see, we always say like we will train the model and then we'll pass the values to find out the, the prediction, correct?
Yes.
So I know that if we have to train with volumes of data, it obviously takes longer time, right? First
Yes.
of all, to understand and all those things. So I don't know, maybe it's in advanced or something. Is it a way that you can store the, model, once you train it, and then you just pass the, new data that you wanted to just get a prediction? That would be very faster, right? Rather than, or
Yes,
is it
that is
like
where,
every? Okay.
yeah, that is where when I spoke about TensorFlow ecosystem, that's where this comes in handy. It allows you a way to store the model and load the model.
Okay, okay. The last.
And anyways, you will be, when you're taking it to production, see, one is model building, right? So, and then when
Right.
you're taking it to production, you need to, it's basically you're giving the operations team, this is my software, you put it in the server for you to run the model to do the prediction, right? So you need to convert it to a form where it can be used for doing the predictions. So TensorFlow has a very good way to support, in terms of saving the model and taking it for deployment also. We
Okay.
saw that briefly when we spoke about the ecosystem in TensorFlow.
Okay, got it.
That reminds me, I told the team that I will be sharing a YouTube video where how a save model is taken to a web application, right? I will share that link. I found a useful link. I'll share that in Teams after the session. I'll share.
Thank you.
So are you with me with respect to recurrent neural networks? Why recurrent neural networks will be required? Do you want me to repeat, or are you understand what I'm trying to convey? Okay, one last recap for this before I proceed. So you have data where the sequence in which the data is flowing in, or the sequence in which things are happening has a role to play. Say, for example, if you're trying to analyze a sentence, then the sequence in which the words are arranged has a weight, has a significance in getting the meaning of the sentence. Or if you're trying to see how a variation of stock price is going to be, how it has varied over a period of time, the way it has been, like in day -2, day -3, day -4, or so. If you're saying like last 6 months, how it has been every day, and then you're trying to predict what it's going to be for the next 2 months, then the sequence has a role to play. Your normal neural network doesn't take the sequence in which the series is arranged into account. So that is where recurrent neural network comes in, where it stores the memory of what the previous computations were there, uses it as an input to do the computation at each node, and that is how the sequence is taken care of. And recurrent neural network is used for for solving such problems. With that, I'll move to an example. We have already spoken about example. This slide also explains why RNN is required. So if you have a time series data, that's an example. Like as I said, like stock price or sensor readings. If you have that, you have medical records, how it has been varying, a patient's medical records, how it has been varying. Those are all examples for RNN application. So they have, how does RNN solve this problem is they use internal state or memory to process a sequence of inputs data. So you do the computation first pass and then store that, use that as an input for the second pass and take it forward. That is how it does. So the output at a particular node not only depends on the input parameter which is given, it also depends on what the previous computation in that node was for the output to be determined. And this is repeated at various nodes, and that's how you get the final output. Why RNN? I explained this. They lack, the traditional neural networks lack the ability to address future inputs based on the past data, right? When I say past data, the sequence is important. This might be a bit confusing because I've said like we take the, say housing price prediction, we take the number of bedrooms, the area, all those parameters, and then this is past data and we are trying to predict the house. So what do you mean by what is different in recurrent neural networks? What is important is the sequence in which where there is significance for the series. Like it is not just based on the input parameters, historic input parameters, but also in the sequence in which the input parameters appear. When that one has a role to play, you need to use recurrent neural networks. I've given a link here. I saw this site when I was researching like how I can present in the class. This site seems to be explaining things in a very simple way. You guys can not only use it for recurrent neural networks, for general machine learning topics too. It has a very simple way to explain. I found it nice, so I thought I'll add it in the link as a link here. You can go through this, but I've explained what is recurrent neural networks, why it is used, why traditional neural networks cannot be used for this purpose. Now we'll look at how this is going to be done. So recurrent neural networks have some elements in which they do that, with which they do that. They have something called as long short-term memory cell. That is, this is for like there is heavy mathematical formula behind this, but I'll not get into that. So they have something, every node, the computation is a bit different. It takes both the short-term memory and the long-term memory, and that is done. There's a mathematical logic which is used. Not only the previous value, there are also like old values that are computed in that it's a node which is taken into account, and you have the long and short term memory which is stored, that is used to influence the output at a particular node. And that's how the relying on sequence is taken care of with this. This is one of the methods using LSTM cells, which is long short-term memory cell. A simplified version of it is a gated recurrent unit. It doesn't take long-term memory into account. It takes the short-term memory. It is computationally more efficient. So there is also a link as to when to use GRU, when not to use GRU. You will see this when I walk you through the notebook. You'll understand like how you will be choosing this. Of course, TensorFlow Keras has a very simple way of building this neural network and giving you the results. So this article talks about like when to use GRU for faster computation. There are some cases where you might not need that, because like the example which I'm going to see shortly, you might it's to determine what the sentiment of a particular movie review is. And for that, like you cannot just do with the immediate set of sequence of words, right? It has to be a longer sequence of words. So for that, you might have to use LSTM. You can't use GRU. So these are the techniques which are used for implementing recurrent neural networks. Because I've spoken about the core which is being done. Once I walk you through the code, how it is being done, then you will understand it in a better way. So I'll pause for a brief while to take questions. I've introduced few terms. I've introduced recurrent neural network and given an example where it will be used, why traditional neural networks cannot be used in those examples, how recurrent neural network achieves this with using the long short-term memory cells or a gated recurrent unit cell. So this is what I've introduced you to. I'll pause here for questions. Okay, I'll take that as a no. I know it might be overwhelming to talk about recurrent neural networks when neural networks itself is complex. What we will do is we'll go through an example. I'm not going to run the code. I've taken this from one of the instructors. I'll show you how it is being done. Like what we saw last time, like we build the model with TensorFlow, building the layers, right? So you can see that happening, but it's slightly different when it comes to recurrent neural networks. Like you need to give some details, like whether you want to use LSTM or GRU, and whether you need to build an embedding layer, basically to prepare the model for taking the inputs. So I'll go through that. We'll see how the model is done for NLP type of applications. Okay, so this is recurrent neural networks with Keras. Okay, so this particular analysis, it is using the data set from Keras itself. Like if you see this, it's a data set which is already present. It's IMDb movie review sentiment analysis classification data set. Basically what it does is there are movie reviews text data which is stored. Based on the text data, we are concluding whether the person liked the movie or did not like the movie. Keep it very simple, binary classification, whether a person liked the movie or not. Okay, it's like a sentiment analysis, what is called as sentiment analysis on the full text of the movie review is what we are going to see. So in this, we will use, because what I spoke about, right? A long short-term memory. We'll use LSTM for this technique, not GRU, because we really don't want to forget the words too quickly, because it's not going to be like if you're looking at a sentence, the person, it's like just the last few words might not convey the complete meaning, right? We need to look at it holistically and come to know whether the person has uh, liked the movie or not. Another case where LSTM could be better used will be when you're translating a particular text, when you're converting it to English, to German, or any other language. You need to look at the sentence holistically, however long it is, not just last set of words and then come to a conclusion. So that is where you need to use both the long and the short term memory. That might be used. That might be a use case for LSTM for in recurrent neural networks. Okay, so the first thing, like always, import all the required libraries. You have the sequence, which will be the simplest model building, which we'll use sequential thing models, layers. We had used dense before. There's one more additional thing, which is embedding. Basically, it is to prepare the inputs for it to be passed as a vector. LSTM is there, and the data sets import is what he has done. Okay, using when you're loading this, like you use this command for loading the data. Okay, we are limiting to the most popular words in the data set, just 20,000 of them, just to keep it manageable. That's what he has done. The data set, you know, that's a data set which is given by Keras. It has 5,000 training reviews and 25,000 testing reviews. For some reason, it's a split which is not like what we had normally seen, right? We have the we have to, usually it's the other way around, but this is how the data set is provided in Keras. So load the data and then look at what the data is. See, if you see the data, we said that it's going to be reviews, right? So it's going to be text data. What we are seeing is numbers. What is that? So what has happened is the words have been indexed. Like what happens is, as a part of pre-processing, in this case, the data in Keras data set in Keras is already pre-processed and given to us. But here, if you see, when you normally get it, what you need to do is you need to do the index of wording, because if you pass the words as it is to the model cannot do anything, because at the end of the day, it is a mathematical computation that takes place, right? So you can't pass like categorical words, categorical variables, you can't pass words to. Model will not know what is the difference between, say, ran, run, or anything of that sort. So you need to convert them into numbers. So one way of doing it is indexing. So what you do is you attach up for a particular word, you attach an index and then pass that. Like if you want to say, I want to conduct class, then you attach a number to I want conduct class and then pass those numbers. The next line, you say, I want to eat. Then what you do is you use the same numbers which you had assigned for I and want in the first sentence. And then to to an eat, you assign new numbers and then generate the index, pass that on to the model for the model to do the computation. So what you're seeing here is actually the indexed values for those words which are passed. The data set itself is pre-processed and given. Since we are showing what the model building is, I haven't gone through the pre-processing part of it, but normally you should do that. And there are several libraries like Spacey which will help you support that. Okay, so if you look at the train labels, as we said, Y label, what it is going to be, it is going to be a binary classification. So you will see either 0 or 1, which means whether the person, he or she, whether he has liked the movie or not liked the movie. Okay. So what we are doing is the words can be like the lines can be of varying length, right? So it need not be, it can be a huge text, it can be a small text. Since we are building the recurrent neural networks, and if you take huge number of words from the review, it might blow up pretty fast. There might be an exponential blow up. So what we are doing is we are restricting the number of words which you are going to take from the review. We are going to take, say, 80 words which are going to be there, and some reviews might not have 80 words too. So what you need to do is, in that case, you need to pad them. Like you need to, if there are missing if it has got lesser number of words, fill the rest of the things as 0. But we are taking it as a standard size. Recurrent neural network takes standard size as an input for this one. Say number of words has to be this particular size. If it is more or less, you need to, if it's more, you truncate it. If it's less, you fill it with, you pad it and then send it as an input to recurrent neural networks. So this is something which will vary from one model to another model, but here we are taking 80 as the max length that is taken. Okay, now we already said that we are going to build using LSTM as the method for the memory cell for recurrent neural network. So we build the model. What is happening is we create the sequential model. These are the layers which we are adding, like what you saw in the hidden layers, right? So if you remember in the previous session, we were adding layers one by one, determining how many nodes are going to be in that layer. But here for doing recurrent neural networks, we are doing the embedding layer, which is going to prepare you for the, it's just a step which converts the input data into vectors, so that the model can take it in and do the processing. So that is taken, and we said that we are going to only take the 20,000 words into account, and 128 is a dimension which has been arrived at for this model building. It's an assumption, and if you see here, this is going to be the number of inputs for the LSTM also. This is the same number which is passed on to the next layer. So you build the embedding layer, which is like converting the inputs to a vector format to pass it on to the, it's a simple recurrent neural network. We've just taken one layer with long short-term memory cells as the nodes. I'll not talk about dropout. I'll not talk in detail about dropout. This is to prevent overfitting of the model. So what it basically does is it randomly deactivates some of the nodes when it's doing the model building so that you don't overfit it. That's a method to deal with overfitting. We'll not get into details, but what it does is you build one layer with LSTM as the memory cell, and you add the output layer, which is going to be sigmoid because it's binary classification which you're using. So this, you build the model. Okay, and after you build a model, as we have seen in the last TensorFlow model building session, to compile the model, have the optimizer, what loss is going to be used. We have like mean squared error in case of regression. Here we are doing a classification problem, so we've just taken binary cross entropy. It's a recommended loss which we can use for compiling the model. Use that, and as the instructor says, it's like if it's going to take a long time to run, so I'm not going to run through this. After you've compiled the model, what you do is you fit the model with batch size and epochs, how many times you need to do all those things, and you also pass the validations data. As I mentioned in one of the previous sessions, when you pass the validation data, the advantage you get is you can do the computation and compare it with what the test score accuracy is also. If you don't pass this, you need to again predict with this model using the test data, get the predicted outputs, compare it with the actual outputs and do it. if you pass it here, you can do it. The model, the library itself gives you a method with which you can easily do that. And in this case, you train the model and then get the accuracy how it is going to be. And for the test score, please remember here there is a huge there's a the high number of test data which is being used, and there is an accuracy which is achieved, which is 80% accuracy has been achieved. So the model has been built. So when what happens is when a new review comes in, do a bit of pre-processing like what we had discussed here. Like if you restrict it to the 80 words and then you pad the sequences, pass it on to the model, you will know whether the person has liked the product or not like the product. In this case, like the movie or not like the movie. So this is how it is done using recurrent neural networks. Any questions? I'm deliberately not going into details of each and every step because it might be a bit overwhelming. First of all, I think we should understand neural networks very well for us to understand, but I've given you an introduction with which like you can always come back to this lecture, go through some of the points for you to understand recurrent neural networks better. So that's the way I have handled it. Let me know if there are any questions. Hello. OK, I'll take that as a no. This is what I wanted to cover in recurrent neural networks. I've covered that. Before we close for the day, there are a few other points, few other announcements. I have shared the code for NumPy, Pandas, and Matplotlib, the commands which you can use for achieving something. It is already shared in GitHub. Mickey has put it in GitHub. So if you want to access that, you can do that. If you need anything like that, please let me know. I can. I know I'm using the material from what I have attended as courses. I don't know whether I can directly share them, but I'll find ways of giving you the details with which like you can look at building models. So if you have any such requests, like if you want to look at how a neural network model is being built using TensorFlow Keras, what are the steps that need to be followed? If you want it in a small Python file, I can do that and give it to you. So please convey those requests through Teams. I'll be able to do that. Um, the idea was to conceptually introduce you to various topics in uh, machine learning and also introduce you to slightly advanced topic in terms of deep learning. That was the aim of this masterclass. Of course, we can't get into each and every level of detail because each topic itself can be a separate masterclass. So I've tried to give you a bit of width and a bit of depth, try to strike the T balance. If you feel I need to dwell a bit more or give you some more details, please be in touch with me. I'll be happy to help. With that, I think we are at the end of the masterclass. So I'll throw it open for some discussions and then we'll close in 10 minutes. I would want you to talk, either chat or unmute yourself and say a few things. Yeah.
One question. In this, you showed that the sample data that data set covers like 5,000 test and 20,000 train or the other way, right?
Yes.
So I mean, I thought like the model will pick basically the split, right? But if you are saying the already the data set is like that, so you can have some separator or way to say that this is a test set and this is a train set for the program.
You can do that. See, what they have given is they have that's the way they have given it and he has just used it. But what you can do is you can look at combining both these things and then split it as test and train set and do it in your percentage and do it, right?
Okay, so
they have
basically
given
you
it
can
as
pass both,
train
right?
and test
Okay.
set itself. So you're using it that way.
Oh, okay. Okay.
Okay, I'll stop sharing my screen. I'll keep the chat window open so that we can hear more about these things. And then there are any
Yeah,
other
so
points you want
Harsha,
to discuss? we can discuss.
Yeah, Harsha, first of all, I wanted to really thank everyone who joined in spite of the pandemic. That shows the continuous learning passion that you guys have. I really appreciate it. And that's what Testopper is all about. We wanted to help you guys to enable that continuous learning mode, that's how I call it as, so that you can be successful in your career. So I wanted to really take time to thank every one of you for joining the session. It's for your own good, and I trust you did get that goodness in it, and continue to keep that goodness by learning continuously, whether through all the programs Testopper that we do or outside of the Testopper programs. It really doesn't matter, but end of the day, we really wanted you to learn. That's my first point I would like to share. And the second one I like to share is a big shout out and thanks and kudos to Harsha for taking time. It's not easy, right? He delivered 6 sessions, and each session is 1.5 hours. But if you had to deliver, if you have done it, you will know what I mean, right? I have done many of them. If you got to deliver a session of 1.5 hours, right? Almost 9 hours of session, it requires at least 40 to 50 hours of preparation. And plus, many years and months of knowledge gathered over the period of time, plus like 40, 50 hours of preparation to deliver this kind of a session. This is the normal, statistics, right? So I wanted to really take a time to thank Harsha for delivering this awesome session, and I'm pretty confident that we all learned together. And kudos to Harsha. Thanks, Harsha, for that. So those were the two key things. And the third thing I wanted to really share with you all is, guys, Testopper, I don't know whether you know or you don't know. For those who do not know, it's a non-profit, and we run together as a team. Every one of you, like Harsha and me, right? We are like you. Okay, we came, we learned, and now we are contributing as a volunteer because we wanted to help you guys to learn. And I sincerely recommend you all to have, if not now, develop such kind of skill set and dedication, and reach out to me and Harsha, and we will find ways how you can help us, to advance this community. And everyone in this community are all volunteers. There is no full-time employees. Every one of us have our own day job, and we take time to help others and help each other. That's what the Testopper community is all about. I sincerely invite every one of you to reach out to me and Harsha if you wanted to contribute and help us to grow this community from 15 people attending to 500 people attending in coming years, right? And we want more people to come together, help together, and succeed together. And that's the only way we strongly believe that Testopper community will grow as a community, as well as individuals will grow as an individuals. So those were my 3 closing notes from me as an organizer and lead volunteer of Testopper community. With that, thanks. Kudos to every one of you. I'll leave the floor to Harsha. Do the honor to respond some of your questions and close the session. Kudos, guys. Thank you, and kudos again.
Okay. So thanks a lot, and your participation helped me. It inspired me to do these sessions. As always, there might be few who are not 100% happy. So if you feel that I need to change my approach in the future sessions, let me know. Open to feedback. If you feel that you can also, what you liked, you can also mention that. That will also help me find out what went very well. I hear a lot of good things. I've been hearing that every session, which is very happy, very nice. It's an attempt. So I'll definitely get better, even better if it was already good. So thanks a lot. It was very inspiring to be part of this.
Harsha, it's a good point, right? I wanted to really articulate on what you said. So it really helped you to become a learner by training. That's what happened. If you think about it practically, it increased your confidence level. Basically, in a long story short, it helped you to become a learner by training, right? You learned by training. And this is the term that I always use. Every one of you here, you today join to learn, right? Harsha learned to train. And every one of you also have to come to a stage where you can train to learn. Because end of the day, whatever you do, you are actually learning. You are not training. Okay, remember this point. I just wanted to kind of relate to Harsha what you said. I couldn't just keep my mouth shut. That was a very important point. Thanks for bringing that up.
Yeah, so see, it's not something new to me. I'll tell you, like 12 years back or something like that, when it was 2008 crisis, right? The company where I was working, like the projects were running, right? But unlike uh, the companies these days, they don't fire people, right? It was more like a cost center. So we had to find ways of keeping us engaged. So what I noticed was I had a domain knowledge in a particular area. I was working for the electronic control unit software which controls the car operation or any automobile, right? So you'll have different pieces of software for that, like air system, fuel system, exhaust system. It's all like controlled by the computer inside the car. So you build software for that, embedded software. So I was working for Bosch. So what we did was I gave this idea to my manager. See, since there is a lull, the projects are not moving. So what we will do is we will look at training people. And when we're training people, it will not be like getting an external trainer and doing it. There are experts in different areas. What we will do is we'll swap that. Say, for example, an expert in air system has to teach fuel system. Fuel system guy has to teach maybe ignition system. So we just swap these things and we conducted those sessions. And this point which Kader mentioned, I heard this from one of the guys too. I learned a lot when I prepared for the session. So from then on, I've been a big fan of learning through teaching. You'll know good amount of stuff, but taking it to people, and when you're about to take it to people, there'll be a lot of questions which might come in. Like when I prepare the slides, like I love to walk through mentally like how I'll be presenting and what could be the possible questions. In that process, like I'll learn new things, I'll search for more material and then try to present it. So it was very enriching experience. In fact, to be very frank, today being the last session for masterclass, I was about to post it in LinkedIn saying that I've completed, and I wanted to mention this exact line. Um, learning through teaching. So I'm going to mention that. So it's good to know that even Kader noticed it.
Yeah, please tag all of us if you can on that post. So yeah, I can relate to what you're saying. We are all learning, guys. We will learn until our last breath, right? There's never a day where we know everything. It's never a day like that, right? So we are all continuously learning, obviously.
Okay, so with that, I'll close the session. Thanks a lot. It was a nice 6 weeks for me. Hopefully it was the same for you, and you could achieve something from these sessions. So going by the feedback, it's been very positive, very encouraging. Thanks a lot. Keep the feedback coming in, whether it's good or bad. And I have NLP masterclass that is planned the second half of the year. We'll let you know, like when it's closer to that, we'll be sending notes about that. So it would be nice if you could join. That will be another interesting topic. We have chosen one topic so that like we can delve into details. Hopefully we'll cover more depth next time too. So with that, I'll close this session, and thanks a lot for your participation.
Harsha, I have one request for you. Please engage
Yes.
the team, right? Please engage the team, whoever has joined your session, in the Microsoft Teams Slack channel, right? It's not only for you and also for the attendees. It's not the session is over today and we are done with it. Continuous learning never is done with a day, right? It has to continue. Please feel free to collaborate, ask questions to Harsha giving inputs and everything happening in the masterclass. And let's make that masterclass channel a really engaging channel for setting a stage for our next session, which is going to happen on September. That's my kind request to you, Harsha, and also to all the attendees.
Okay, sure.
Awesome.
Okay. Thank you.
Good job, Asha.
Thanks, Samuel.
Okay. You'll be there on Monday, right?
Yeah, I'll be there on Monday.
Yeah, I sent a note last time. I wasn't able to join because I had a meeting.
Yeah, no issues. We joined. I think Navina and Mickey joined, and we had few discussions on the courses Navina is going through, and then we closed with that.
Okay, so
We
I'll
can
catch
talk
up
again on Monday.
next Monday. Okay.
Yeah, yeah. Guys, in case if you know anyone or you or anyone who is expert on 4G, 5G telecommunication, software development, testing on the hardcore stack of 4G, 5G, please reach out to me in the Microsoft Teams. If not you, if you know any of your friends who have lost job in Canada and things like that, reach out to me. Feel free to. Okay. Take care, guys. Harsha. Awesome,
Okay.
man. Kudos.
Thank you.
Take care. Bye-bye.
Bye.